Hi everyone, this figure is an example of an isolated survey plan. This video will illustrate on how to prepare an isolated survey plan just as this. Okay, so the title of my video presentation is Preparation of Isolated Plan for a Simple Subdivision Survey. Before I will proceed, I would like to discuss or define what is survey plan. So basically, survey plans are plans or drawing of cadastral lot being surveyed by a geodetic engineer, and that plan will be submitted at the DENR Land Management Services for verification approval of survey being conducted. In the Philippines, there are two types of survey plans. One is a cadastral survey plan, and the other is isolated survey plan. The figure on the left represent a cadastral survey plan, wherein it shows uh, boundaries of cadastral lands. It shows the meets and bounds of the cadastral lands inside inside a locality. It could be a barangay, municipality. Okay. The right side is an example of isolated survey plan. So as the name suggests, isolated. So it is a drawing of only one cadastral lot. Okay, an example, or it could be a drawing of a consolidated of one, or no, consolidated of two or more cadastral lands. Okay, so this video will illustrate or will focus on the preparation of isolated survey plan. So in preparation of isolated survey plan for verification and approval at the DNR Land Management Services, the geodetic engineer will use this form, LMB form number GSD.C-7. Okay, so this is a the standard format to be used by a geodetic engineer. For in this space represent the drawing space or where a GE draw the cadastral property. In the center, uh, this is the center point of the property. Here, the northings of the center point is being written, and of course the eastings of the center point will be written here. On the right side, the top portion are the details of the lot or cadastral lot being surveyed and the details about the geodetic engineer who conducted the survey. Below are space or is a space for the signature of the verifiers. Okay, so there are several types of isolated plans. One is original survey. Second is subdivision survey. This is what we are going to prepare. Consolidation survey. This is a survey wherein a GE is consolidating two or more cadastral lots. Fourth is consolidation subdivision survey, a survey wherein two or more cadastral lots being consolidated and then subdivided. And other plans, for example, parcellary survey and others. So before we will discuss or before I will illustrate how to prepare the isolated plan, I would like to introduce first what is a standard scale for isolated plan, or what is the standard scale that will fit inside the LMB form number GSD C-1. Okay, so this is the, or these are the standard scales uh, based on the DNR Memorandum Circular number 2010-13. So we have 1 is to 100, 1 is to 200, 1 is to 300, 400, 500, 600, 800, then 1,000, 2,000, 3,000, up to 10,000. So it's easy for you to memorize because it's like 1, 2, 3, 4, 5, 6. There is no 7. And then directly to 8. Then from the, then 1,000. So just add zeros to this one. 100, 200, 300, 400. So that would be the succeeding standard scale for isolated plants. Okay? So when to use the scale? So you have to look at the maximum difference in coordinates. So these are the range of the maximum difference in coordinates. If the maximum difference in coordinates is 0 to 30, then you have to use a scale of 1 is to 100. If the range or maximum difference is between 150 to 180 meters, then you have to use 1 is to 600. Okay, so there is no 7, so it's easy for you to remember because just imagine a triangular scale or just like a Toblerone. So a Toblerone has 1, 2, 3, 4, 5, 6 faces. Okay? So this is yung face na yon represent one scale. So 1, 2, 3, 4, 5, 6, and there is no 7. There is 8 because 8 came from 400 times 2. Okay? And of course, 1,000 came from 100, just add 0. Okay? So or you may use a formula in computing the standard scale. Okay? So one option is you have to follow this table. The other one is you have to use this formula. Standard scale is equal to maximum difference in coordinates divided by 0.3. Okay, so to illustrate, I have this example. Here, compute the standard scale of the following maximum difference in coordinates. So you are given the maximum difference of, we have 28, 30.1, 29.99, 240.01 meters. So using the formula, or if I will not use a formula, so the 28 is within this here or somewhere between 0 to 30. So of course the scale is 1 is to 100. 30.1. 30.1 is between or somewhere within 30 to 60. So the scale would be 1 is to 200. 29.99, it's somewhere here. So the scale would be 1 is to 100 still. And 240.01, it's about here. So 240.01, it's the scale should be 1 is to 1,000. Okay, so that method is using this table. Okay, so how about if we are going to use the formula, this one? Okay, so of course for letter A, so that would be maximum difference is 28 divided by 0.3. Okay, then simplifying, that would give you 93.33. Okay, so of course it would be 100. So the scale is 1 is to 100. This one, 100.33, although it is closer to 100, but we rather use 200. It is because that if we use 100, then the scale or your drawing might exceed, no? Might exceed the margin. Okay, so that's why you have to choose the next lower scale. Okay, so the scale for this one is 1 is to 200. So if you check on the table, 30.1 is somewhere between 30 to 60. So it's 1 is to 200. Next, 29.99 divided by zero point 0.3. That is 99.66. Yeah. So it's 100. Okay. And it's 1 is to 100. So even uh, the answer is 100.01. Okay. For example, 100.01, you have to use 200. You never go, I mean, hindi pwede na you have to round down, but you have to always go to the next higher number. Okay? Okay, so next is 240.01 divided by zero point 0.3. It's 800.033. Okay, you might think that it is uh, closer to 800, but again, as what I have mentioned, that 800 is not the standard scale because it exceeds 800, so it might uh, that your drawing might be exceed the boundary or the margin of the drawing space of the LMB form. Okay, so therefore you have to proceed to the next higher. After 800 is 1000. So therefore the scale is 1000. Or check for using this table 240.01. So it's somewhere here. So the scale is 1 is to 100. So that is about determining or identifying the standard scales. Okay, when I say standard scale in this video, I am referring to a scale that in order for a drawing to fit inside the LMB form number GSD.C-1. Okay, again, this is in accordance with the DNR Memorandum Circular number or DMC number 2010-13. So this is the title of this memorandum circular is actually Manual of Land Surveys in the Philippines. Okay, so geodetic engineers, we usually this manual serve as our Bible in the practice of survey or the practice of geodetic engineering. Okay, so if we refer, if we look back now, standard scale, uh, we have to use the maximum difference in coordinates. So what is maximum difference in coordinates? Or how are we going to compute maximum difference in coordinates? Okay, so here, when we say difference, it is either the horizontal distance between extreme eastings or the vertical distance between extreme northings. Okay? Then of course, maximum difference is higher value, is the higher value. Okay, it could be horizontal or vertical distance. Okay, for example, the property represented or the lot boundary represented by a black line. So the maximum difference here is horizontal distance. It is because that the width, the width of this property is longer than the height. Okay? Height of the property. Okay? This one, the maximum difference here is vertical. It's because the vertical height of the property, represented by orange line, is higher or longer than the horizontal distance, okay, or being represented by a blue line. Okay, so how are you going to compute the maximum difference? Okay, so of course, first you have to locate the extreme northeastings or northings values. Okay, for example, this is the property. Okay, we have these vertices. We refer this one as corners of the property. And what or where is the extreme easting? So extreme are these values, no? The one on the leftmost and rightmost corner. This is the extreme eastings. For extremes northings, those are corners or vertex that is located on the topmost, no? On the northmost one. Okay, that is extreme eastings. And extreme northings are these corners, no? One and this one, no? The northmost and the southmost. Extreme eastings, uh, the east, no, the westmost and the east corner. Okay. Next is the you have to subtract the true or the two extreme eastings. That is, if you have to the value of this one minus the value of this one. Okay, or what is the eastings of this point? Then subtract it by the value of this easting. Okay, so if we recall, eastings is 0 here, and then it is increasing to the right indefinitely. Okay. Next is you have to subtract the two extreme northings. So it would be northings this one minus northings of this one, because we are after of this length. Okay, this length. And this one, that is also this length. Okay, the horizontal distance between this point and this one is the vertical distance between this. The next thing you are going to do is you have to select the higher difference. Okay, for example, in item number 2 you get 100, and item 2 you get 200. Then you select the higher, so you have to select 200. So that value that you selected is the maximum difference. Okay, so let us have an okay, so for example, you are given the coordinates of the lot boundary, and you are asked to solve what is the maximum difference and standard scale for isolated plan. Okay, so you have the corner numbers, the eastings and northings of each corner. Okay, so for solutions, first, okay, so we have to go back to the scale. Standard scale is equal to the maximum difference in coordinates divided by 0.3. So solving for the extreme distances. Okay, okay, that would be, so to find the extreme points, again, extreme points, you have to look at the highest in the northings, highest and lowest in the northings, and highest and lowest in the eastings. Okay, so for northings, the highest value is 1782, and the lowest value is 1466.57. Okay, so substituting the value, it would be the value would be 316.18. Okay, so for extreme distance in horizontal, that would be the highest eastings value, which is 33,000, 3,305.59, and the lowest is 2,875.40. Then subtracting the two, you get 430.19. Okay, so these are the horizontal and vertical distances, okay, or the horizontal and vertical dimension of the lot boundary. Okay, so next is you have to select the higher difference. The higher difference is 430.19 meters. So therefore, the maximum difference is 430.19 meters. Okay, so you have to choose the highest, the higher. So we are done with solving for letter A, which is the maximum difference. Next is you have to compute, or we have to compute the scale. Scale is equal to the maximum difference divided by 0.3. So substituting, our maximum difference is 430.19 divided by 0.3. We get this value, 1433.962. Okay, so if we look back the table, okay, if we look back the table, the value next is we look back the table, 1400 is somewhere here. um, where is it? Okay, so the answer is 430. 430 maximum difference is between this value 300 to 600. So the scale is 1 is to 200. Or using the formula, we came up with this 1433. So there's no 15, there's no 16, but we will proceed with 1200. So therefore, the scale, the standard scale for this boundary lot or lot boundary is 1 is to 2000. Okay, so we are done with determining the standard scale of the isolated survey plan. Okay, so we will proceed with the subdivision survey plan. Okay, so what is a subdivision survey plan? So for illustration purposes, an example here, for example, this rectangle is a rectangular lot. We call that one as lot 100. Okay, and we subdivided, or you, this property is being subdivided into two. Okay, so one lot 100A and lot 100B. Okay, so for the information of everybody, and if we refer that in our manual, if we divide a property into several sublots or subdivision lots, we have this dash A. If this is numerical, then it would be, the next would be letter. Okay? Or if this is uh, letter, then it would be dash 1. Okay? Uh, for example, the lot being subdivided is lot 1, 2, 3, dash C. Okay? Meaning this property is being subdivided into 3. Then the resulting lot number would be 1, 2, 3, dash C, dash 1, 1, 2, 3, dash C, dash 2, 1, 2, 3, dash C, dash 3. Okay, so that is the pattern. Number, number, letter, number, letter, number, letter. But anyway, I would like to, what I would like to emphasize here is what is a subdivision survey. So you have a property here that, and then being subdivided into two or more sublots or subdivision lots. Okay, so the term here, the one or the property being subdivided, is a mother lot. Mother lot is the original boundary of the lot being subdivided, which is shown as red polygon in the figure. For example, lot 100. Then the resulting lots after subdivision is called or are called sublots, which are shown as enclosed by a uh, red and blue lines. Example, lot 100A and lot 100B. So that is a subdivision survey. Okay. Next, I would like to emphasize is the lot corners. Okay. Lot corners are basically the vertex or vertices of the boundary lot or lot boundary, or it could be the vertices of the polygon. For example, this one, a rectangular lot has 4 corners. Okay, and to draw that corners or to represent that corners, you have to draw a circle. Okay, circle on the vertices. Okay, for example, you have 1, 2, 3, 4. Now, once the mother lot is being subdivided, it will create a new corner, new vertex. Okay, so this, for example, this one. Okay, so to show the new corner and the old corner, so old corner are, or old corners are represented by a double circle, just as this one. Okay, and new corner will be represented as a single circle. Okay, so if you can see a plan, an isolated survey plan, and you will see double corner or double circle and single circle, so you can have a hint that those, the simple, I mean double circle, are old corners or the corners or vertices of the motherland. Okay, the other thing that I would like to emphasize is that the corner label. Okay, corners are numbered accordingly in clockwise direction. Again, it should be in clockwise direction. For example, 1, 2, 3, 4. Not as 1, 2, 3, 4. It should be in clockwise direction. Again, this is based in the land surveys or manual of land surveys in the Philippines. And here, in the subdivided lot, you created another corners. Okay, so of course the corner of this sublot are 1, 2, 3, 4. Okay, for this sublot, lot 100B, the corner would be 1, 2, 3, 4. And then wherein the corner 2 is also corner 2 of the boundary or mother lot. Okay, and here also corner 4 of lot 100A is equivalent to corner 4 of the boundary or motherland. So meaning to say, that is only one point on the ground. The double circle represent only two corners, okay, or more than, it represent more than one corner, but it is being represented as one point on the ground. Okay, so again, lot corners are represented by circle, old corners as double circle, and single circle for new corner. And the label are numbered accordingly in clockwise direction. Okay. Okay, so we will proceed with the 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 basic or the main purpose of this video, which is the preparation of isolated plan. So how to prepare a plan in a CAD software. Okay, so these are the steps. First, of course, you have to plot the type point. Okay, so although this is optional, depending on how are you going to present the technical description, which I will be discussing later. Okay. Okay. Next is plot the mother lot. So you have to plot first the mother lot or the boundary lot. Okay. Next, the sublots. Hindi pwedeng sublots first and then mother lot. It should be mother lot then sublots. Okay. How to plot that, you have to refer to our exercise number 2. Okay, so after computing the sublots, you have to compute the area of each sublot. Okay. Then points must be indicated with circle, double for old, and single for new corners. Then you have to label the lot number, area of each sublot. Or if there is claimant or owner, you have to label as well. Next is you have to prepare the technical description and check the technical description if it conforms with the boundary. And one thing that I missed to mention here is that you have to identify the standard scale. Compute the standard scale. Compute the standard scale. So this is necessary in plotting of your drawing or printing rather, not plotting. Okay, so then after that, label the adjacent boundary of the mother lot. Okay, so how to compute the area? So if you are doing a manual method, you may use DMD or the double meridian distance, which you had in GING 111 or the double parallel distance. Or you may use the Excel, so to automate the process. That is for manual method. For AutoCAD or CAD software, basic specifically the AutoCAD, you have to type list or LI in the command line, then enter, then the area will be presented, including the coordinates of each corner or vertex. So after you plot, you have to draw the circle. Okay, so we will not I will not present in the PowerPoint how to plot type point, mother lot, sublots, but you have because you already had that in GING 111, but during the demonstration later, I will present. I will show how to do it. So you have the scale, then points, you have to draw the circle. So how to draw the circle? How to draw? Of course, you have to draw a circle, but what is the size or the diameter of each circle? Okay. So according to the, again, DMC 2010-13, the diameter of a corner must be 2 millimeters. Okay, 2 millimeters. So if you notice, no, when you draw in AutoCAD, you are actually drawing the ground distance or the actual distance. Okay, and then when you print that, what you draw in AutoCAD, then that the result or the printed figure, the printed plot is the map distance. Okay. So for example, suppose the computed standard scale of the plan is 1:200. What is the actual diameter of the circle to be drawn in a CAD? No? So you will draw in a CAD or AutoCAD. So what should be the dimension or diameter of the circle? So that when you print that in a scale of 1:200, it will appear as 2 millimeters. Okay, so recall, we have a map scale formula. Wherein scale is equal to map distance over ground distance. Okay, what is a scale? The scale is 1:200. 1:200 is equal to 2 mm over ground distance. The 2 mm, this is actually the diameter of the circle. That should be appearing, on the printed plan or survey plan. So the ground distance, this is what we should draw or you should draw in AutoCAD. So that is the ground distance. So manipulating the formula, you will get 400 millimeters, or that is 0.4 meters. Okay, so in other words, you have to set the diameter into 0.4 meters so that when you plot the drawing in 1:200 meters, or when 1:200 scale, that circle will appear as 2 millimeters. Okay, so there you go. Another example. Suppose the maximum difference of the coordinates of the mother lot is 111 meters. What is the actual diameter of the circle to be drawn in CAD? Okay, so you have the maximum difference coordinates. Now, so in order for you to identify the actual diameter of the circle, you have to know the scale. And here you are only given a maximum difference. However, you can compute the scale using the maximum difference. Using the formula you have. Okay, so to identify the standard scale first, because this is necessary in computing the actual diameter of the circle. So standard scale is equal to maximum difference in coordinates over 0.3. Substituting, you have 370. The next higher number of 370 is 400 based on the table or based on our manual. Okay, so therefore the scale is 1:400. Once you have the scale, you will now know the actual diameter using this formula, which is from the map scale. 1:400 is equal to 2 millimeters over the ground distance. Therefore, the diameter of the circle to be drawn in a CAD is 0.8 8 meters, or that is 800 millimeters, so that when you print the map or plan in a scale of 1 is to 400, then the circle would appear as 2 millimeters. Okay, so that is dimension of a circle. Okay, so after that, you have to prepare the technical description. So we are in the here. Okay, preparing the technical description. I skip on the lot number and area because I will demonstrate that in AutoCAD later. Okay, so prepare a technical description. So what is a technical description? Okay. So technical description, this should be placed also on a survey plan. So there are two formats of technical description. One is this one. We have line, bearing, and distance, and then boundary, meaning the technical description of the mother lot, the lot that is being subdivided. Then you have line, line 1 to 2, what is the bearing, what is the distance. Line 2 to 3, what is the bearing and the distance, and so on and so forth. Then, followed by the sublots. Okay, suppose the lot or the mother lot is 100, then the sublot would be 100-A. Again, 1 to 2, bearing and distance of 1 to 2 of the sublot 100A. Okay, and so on and so forth. Next is 100-B. Then you have here tie lines. This is the line connecting the tie point to corner 1. So that's why you have lot number, bearing, and distance. Tie lines from BLLM number 2, because the tie point here in this survey, for example, is BLLM number 2. So for the information of everybody, BLLM number 2 is Bureau of Land Location Monument. So ito yung mga malalaking reference point. No? Aside sa Muhon, mayroon tayong mga malalaking mga points na that are being established by a concerned authority or authorized agency such as the NAMRIA or DENR. Okay, so back to the tie line. So you have tie lines from BLLM number 2, PSC 5, by cadastry to corner 1. Okay, so meaning from BLLM number 2 to corner 1 of the boundary. What is the bearing? What is the distance? For 100-A, what is the bearing? What is the distance? Etc. The other format is that the tie line is already embedded now in one table. Okay, unlike here, you have this table and then followed by another table for the tie lines. So here you have boundary, same thing, boundary, sublots. But for here, instead of 1 to 2, it's TP to 1. So basically, it's here. No? BLLM number 2 to corner 1. What is the bearing? What is the distance? Okay? And so on and so forth. And there is a note here, no? If you are using TP here, so you have to put here what is the TP or tie point of that survey. So in this case, my TP is BLLM number 2, PSC 5 by cadastre. That's the complete name of my TP. Okay. So, question. How to compute the technical description of the property? So, of course, you have to use the coordinates. Okay, we have that in Jing 111. Using the coordinates, and you can get the bearing and distance. Okay, so after having or filling up this table, you have this number already, bearing distance, etc. Then you have to check the technical description. So, for example, this is the technical description of the mother lot. Okay? Mother lot or lot 100. So here, this is due east 100 meters. This is due south 50 meters, due west 100 meters, and due north 50 meters. It is being subdivided into this one in a way that the division line is parallel to this eastern side, no, western side of the mother lot, and a distance parallel and a distance of 30 meters. So meaning to say, if this is 30 meters, then the distance from corner 1 to 2 is also 30 meters. Okay? And this is also 30 meters because the example here is a regular rectangle. Okay, so if this is 30 and this is 100, of course, now it should be 70 due east. It should be 70. Suppose when you compute using the coordinates, it came up of 69.99, or it might be 70.01, or there is a small error in the distance. Then you have to adjust in such a way that this should be 70. No? So you have to put some erasure and then write 70 so that it will conform with the original boundary. Okay, so 30 plus 70, it's 100. Same thing for this one. This is also 100, so this should be, if this is 30, then this should be 70. And of course, uh, line 2 3, okay, line 2 3 of lot B is 50 meters due south. It's due south because it's going down. It's not like that. Okay. And then the technical or the bearing of 4 to 1 of B is, this is parallel. So it would be due north, and it's also 50 meters. Okay, so that is how are you going to check the technical description. So meaning to say, line 1 to 2 of 100 is equal to the summation of these distances. Okay, and line 3 to 4 of 100 should be the summation of these two distances. Okay, and of course the area of this whole lot, or the summation of this whole lot or the summation of these two sublots should be equal to the area of this mother lot. Okay, so that's is why you have to be very careful in computing uh, in writing the technical description of this of the sublots. Okay, so we will proceed with the demonstration. So for demonstration, I'll be using the data. You have lot 101, 2, 3, which is the mother lot, and I have these eastings and northings. The area is 76,579 square meters, and its subdivision line details. Lot 1, 2, 3 is to be subdivided into two parts, such that the dividing line will start at the midpoint of line 1 to 2 and end at corner 4 of the mother lot. Okay, so to illustrate that one, uh, I will copy. Okay, so for the demonstration, I have here the data which I copied from the PowerPoint so that I will not go back and forth to the PowerPoint presentation. So I have the corners, the eastings and northings of each corner, and also the subdivision line details. Okay, so as according to as what I have presented a while ago, you have to plot the mother lot. So this is the mother lot. Okay, after mother lot, you have to plot the subdivision lots or sublots. Okay, so to type or to plot the sublot, mother lot by coordinates, you have to type PL in the command line. Okay, PL for polyline. Okay, enter, and then don't click on the screen. So it will ask you specify starting point. Okay, so don't click, but rather just type the stings of the corner one. So 3,000.93, comma, northings 1782.75. Enter. Okay, so that is the corner one. Okay, so don't uh, mind because your corner one is somewhere there below. Okay, based on the here in my in my video. Okay, so next is you have to plot the next point. Next point is corner 2. So no clicking on the screen, but just type the coordinates. So uh, shift that one. So hashtag 3305.59, comma 1689.99. Enter. Okay, so I just plotted corner 2. The next point that I'm going to plot is corner 3. Again, no clicking on the screen. So shift 3 or hashtag 3270.29, comma 1466.57. Enter. I just plotted corner 3. Then hashtag 3110.76, comma 1547.58. Enter. Okay, so finally plot corner 5, 2875.40, then comma 1567.18. Okay, so I'm done with plotting corner 5. Then I have to close, no? Close the polygon. So type C for close, enter. So you cannot see, you might not see the polygon. So to view that, so you have to type Z, Z for zoom, then E for extent, so that it will display the extent, the whole extent of the drawing. So E, extent, enter. So where is it now? It's here. So I will erase or I will move this uh, instruction here so that I can see. So this is me. This is the boundary or the motherland. Okay, I will move again. make it smaller. Okay, so this is the mother lot. Okay, so next is you have to label the corner. You don't know where is the corner yet. Okay, so to know the corner, where is corner 1, 2, 3, and 5, so you have to click on the that feature on the polygon and then type properties. Okay, properties to display the property of the polygon. So you will see here, it will give you the geometry, and then there is a symbol, current vertex. So that is 1, okay, corner 1. That is vertex number 1. Okay, so if I will click on the arrow down, it will display as 5. So meaning this is your corner 5. And if I will go up, it will go back to corner 1. Then this is corner 2, corner 3, 4, and 5. First, then go back to 1. So next is I have to label or indicate the circle. So what is the circle? Okay, what is the dimension of the circle? So we already computed that the circle, I am using the same data for our example, our previous example. So the scale is 1 is to 2000. So if it's 1 is to 2000, then my circle would be 2 times 2000, it's 4000 millimeters, or that is 4 meters. Okay, so I will draw circle, then specify it should be endpoint. The diameter would be 4 meters. Okay, again for this one, enter, this one, enter, this one, enter, this circle, enter. Okay, so again, property, the diameter of the the diameter of the circle should be that is 2000. Let me check. Is it 2000? Yeah. 2000 times 2 is 4000. So 4000 should be sorry. I mistake. No, it should be, yeah, the it should be diameter should be 4, not radius. I will edit one. Okay. So it should be 4. Enter. Ayan. Okay, so although it appears as very small, but when you print that one, it will appear as 2 millimeters. Okay, so the next thing is you have to label the corner. So you may say the text. This is corner 1. What should be the height? Height should be, it's also 2, that is 4 mm. 4 mm times 4, it's 16, so it's 16. So 160. I mean 16. Enter. So 1. I think it's 2. The scale should appear as 3 mm. So 3 mm times 1 is to 2000, and it should be dtext. So the height should be 3 mm. So if it's 3 mm and then the scale is 1 is to 2000, so 2000 times 3 is 6000, or that is 6. The height should be 6 meters. Okay, enter. Height, specify height 6. Okay, sorry. Okay, by the way, no, before you plot, you have to check on the units, no? So units, and then you have to, yeah, I set on surveyors units, precision, and then the important is this should be in meters. Okay, so it's already in meters because I already set this a while ago. So again, you have to label the corner. Starting point should be here. Height should be 6 meters. Okay, so this is 1 meter. This is 2. This is 3. This is 4. And this is 5. Enter. Okay, so these are the corners of the lot 1, 2, 3. Okay, so back to the subdivision details now. So we are done with plotting the mother lot. The next thing that we're going to do is you have to plot the sublots. No? So sublots is created by a subdivision line. So lot 1, 2, 3 is to be subdivided into two parts, such that the dividing line will start at the midpoint of line 1 to 2. So where is 1 to 2? This one. And end at corner 4. So where is corner 4? This one. Okay, so we will draw the subdividing lot. Subdividing line. So line, enter. Then it should be midpoint. So you click mid. Okay, mid. So the symbol triangle refers to midpoint. So that is the midpoint between 1, 2. And then click on that. And then this one. That is the dividing line. So it divides the lot into 2. So there are how many new corners? New corner is only 1 because this one is on an old corner. Okay? So next is you have to label, create a sublot. Okay? It should be a polyline. No? With regards to layer management, it's better to separate a layer so that it would easier for you to change the layer style. Okay, so I have here create new. So maybe I will call as mother lot or maybe boundary BDRY. Other layer might be sublot, or it could be lot 123-A. Okay, or I rather put that one as sublot. Okay, sublots, and this might be corner. Okay, so corners are red, appears as red. Sublot might be blue. This is only for my purpose, and maybe the boundary would be green. Okay, so the boundary is, I will set it as boundary, and for sublot I may call that one as 123A, and this one is 123B. So I will label for MTEX. I like MTEX, no? Because you can adjust the character spacing. Okay, so this is lot caps lock. Now lot 123 dash A. Okay, the area is, we don't know yet the area. We'll put later. And you have to character line spacing, this one, or maybe center, and then This is sublat. Copy. This is sublat. I mean lat 123b. Okay, so for sublat boundary polygon, okay, so I will type PL for polyline, then start here. This is corner 1. Okay, so it's good that there is a common corner for corner 1. Okay, so here, this is, I start the corner 1 because the mother lot for the corner 1 of mother lot starts here. So 1, then this is 2, this is 3, and 4, and then close. Okay, so the area, okay, later. Next is PL. So we have maybe 1, this is 2, and this 3, 4, and then close. Okay, so you have now the sublots, but you forgot to add the layer, I mean the label of the corners of the sublots. Okay, so put circle first. Circle should be here. Diameter should be 4 meters. Is it 4 meters? No, it should be 2. Circle, I mean radius should be 2 so that diameter will appear as 4 meters. Okay, so this is new corner, and this one are old corners. Old corners should be circle. So it's, if this is 2, so just 1, 2, 1.5, 1.5. Okay, copy this old corner, old corner, old corner, old corner. Okay, and this is also old. Okay, so you have the old corner. So I have to set on the layer style. The layer style should be corner. Okay, and this is corner. This is also corner. Okay, and then the label, the text, this is 1. So take note that the corner of the sublet should be written inside the sublet. Okay, 2, 3, and 4. Okay, so corner 1 is here. Just check. You just check this one. Properties. Okay, so corner 1 is there. Corner 2 is there. Okay. So the text corner 1, it's 1, 2, 3, and 4. Okay, so all the corners are already labeled accordingly. Okay, so next is for the area. So for area, for each sublet, you have to click on the polygon for the sublet. So click on that and then type Li for list. It will give you the coordinates. Okay, so this is X, this is eastings of corner 1, and northings of corner 1, corner 2, corner 3, and corner 4. The area is 449 or 4,000 paste 4,924. So remove now. So you may round down or round up. Okay, so this time you have to round down. The square meters. Okay. Okay, then for this one, click on the polygon LI. The area is 34,000.69. So this time you have to round up. Okay, so round up. It's 0.69, so it should be 0.16. Okay, square meters. Okay, so there, we don't accept decimal point areas. It should be in a whole number or in integer. Okay, so to check the area, total area, so click on quick calc. Okay, so you have 41963 plus 34616. Okay, let us check if it's equal. This one. Okay, enter. 76,579. So 76579. Let me check. Mm, yeah, that's correct. So 76,570. So after that, you have to put in the sketch in the on the template. Okay, so on the template. So the standard template actually is set is to 1 is to 1. No? So if you want to put this inside the template, you have to scale the template. Okay, so this is the one. So we're done with plotting the subdivision lots. So next thing is you have to set the adjacent corners. I mean the adjacent lots, but this time I will not illustrate anymore because it's self-explanatory on the lab guide. Okay, so that is all about preparation of isolated plans for subdivision survey.